There are basically two ways how you can use Apache Spark. You can either run an interactive session, or you could submit a Spark job in form of a script or jar file. Also, notice that we can choose one of the following three programming languages to interact with Spark: Scala, Python, and R. In this video, I'm going to show you how to interact with Spark using Python and Scala, since the APIs for those two languages are more mature than the prevailing R packages. As of now, we only have a small test CSV file on our HDFS. Later, we will download a dataset that is a bit larger and then put it into HDFS. Then we are firing up interactive Scala and Python sessions in which we will read in the data. Afterwards, we will prepare a Python script and a jar file, which we will then submit as a job to our cluster, which are also just reading in data into Spark. First, let me show you how you can create an interactive session with Scala and Python respectively. Also note that we will make use of the queues we defined in the jar configuration files. Alright, so first bring up a terminal. Now, you should always make sure that your Hadoop cluster is actually running. You can run Spark without a Hadoop cluster, but in my case, we want to use one. So, as always, just log in as the Hadoop user. All right, then first of all, let's start the Hadoop cluster. So start dfs.sh. And as soon as that is done, we're going to start yarn by running start-yarn.sh. All right, so start-yarn.sh. All right, everything is running. We have the name node, data node, and the resource manager. Perfect. So let's get started with Scala. First, move into your Spark folder. So we know that our Spark folder is in our home directory, and it is called Spark-3.0 and the stuff following that. So cd Spark. All right, and then let's go into our bin folder. Let's show the content of that folder. And here you can see several programs that can be used to interact with Spark. In particular, we now want to use Spark Shell, which will create an interactive Scala session. And that session, it will automatically create a variable called Spark, which will hold all the necessary information to interact with our current Spark session. Of course, we must tell it how to connect to our cluster and what queue should be used. We do that in the following way. So we say .spark-shell. Then we say master is yarn. So we want to connect to the yarn resource manager. Queue, so queue is diff, and name is interactive. Interactive. And then hit enter. So a lot happened in that command. Let's digest it. So first we chose to run the Spark shell file, which will create an interactive Scala session. Then we told it that we would like to connect to our cluster by working with yarn. If we wouldn't use yarn, we could give a specific Hadoop root. However, in this case, we only need to give it yarn since we defined where to find the yarn and Hadoop configuration files. Given those files, Spark will figure out how to connect to the Hadoop cluster by itself. I think that is pretty neat. Next, we tell it to use the queue def. And remember that we have to find two queues in our scheduler, prod, and def. Hence, it will only use resources of the def queue. And the last option is name, which we set to interactive. This will be the name of our interactive application, which we will later see inside yarn. All right, so as you can see, an interactive session was started, and we could type in Scala commands if we would wish to. However, before we do that, let's have a quick look into the yarn UI. So bring up Firefox and go to localhost :8088, hit enter. Here you can see we currently have one running app. And if you click on it, you will see that there's our application interactive. So that's the name interactive with a bunch of additional information. Now, if we click on running applications, there you will see it again. We have one running application. If we would end the Spark shell, the application would no longer be active. But before we go back into our shell, remember that we only had one small example data set. This isn't really something to go with, so we will first upload a new data set into HDFS. So we are in Firefox and we can search for a new data set. Now let's Google Titanic dataset. So Titanic dataset. Hit enter and then it's still loading, and then click on a link of the University of Stanford. So there it is. Click on it. And here we can find a data set on the survivorship of Titanic passengers. This is hardly big data, by the way, but the ideas I show you scale to arbitrary sizes. So copy the link of that data set over there. So we say copy link location, because that is the CSV file. We have now copied the link of the Titanic dataset, which is a CSV file. Now let's go back into our terminal, but not the Spark shell, but a new one. So create a new terminal. Oops, sorry. And I gotta log in as the Hadoop user again. All right. And now you can enter wget and paste the link of the dataset. All right, it downloaded the dataset, and as you can see, it's right over there in our home directory under titanic.csv. All right, next we need to put that into HDFS, and you can just upload it to the root directory. So we're going to use the HDFS file in our Hadoop folder. So Hadoop, and then bin HDFS, and we're going to use dfs -put. And then the file we want to upload. So in our home directory, it's the Titanic file. And we just want to put that into the root directory and name it Titanic. Titanic.csv. Then hit enter. And the data was uploaded. So it's now on HDFS. I mean, we can check that if you want. So we can say Hadoop bin HDFS. Oops, sorry, HDFS. dfs ls, and then check the root directory, and there it is. So as you can see, we have a Titanic file over there. All right, so fantastic. Now go back into the terminal containing the Spark shell. Here I want to read the CSV file from HDFS, and this is actually pretty simple. So again, this is our interactive shell terminal, so where we have this interactive Scala session. And what we want to do is we want to read that CSV file into on HDFS, that CSV file that resides on HDFS, into a data frame. So let's say val_df equals spark.read.format, and now we gotta give it a format. It's a CSV file. We want to use a header, so we say option header true. We want to say that it's separated. So the separator is a comma. And we say loaded. And the way we access the HDFS is actually pretty simple. We just say HDFS : let me expand that so you can see everything. So it's HDFS : // So we are now in our root directory. And then we say titanic.csv. Hit enter. And now it's loading into the data frame. Okay, so this command will read the CSV file and save it as a Spark data frame under df. As you may know, Spark is lazy and only evaluates the commands when it really has to. So let's show the first 10 rows of our data frame to see if it has really worked. So we say df.show. We want 10 rows and false. There it is. The show method on a Spark data frame takes 2 arguments: the number of rows to return and whether or not it should trim the columns. So it looks like the data was read incorrectly. That worked great. Let's get out of the shell by entering Control-D. All right, we are now out of the shell and we are back in the bin folder of our Spark folder. So the interactive shell has been terminated and there will be no running application in Yarn. So let's do the same for PySpark. So we say PySpark, and then master is Yarn, Q is def, and name is interactive. Then hit enter. There it goes. As you can see, it's the same syntax. We only replaced spark-shell with PySpark. We are greeted with a command line interface ready to take commands. Again, we want to read in the CSV file and print the first 10 rows to the screen. So let me clear the screen. So we say df equals spark.read.format CSV. So that's basically the same. And we say option, header, still the same. However, note that true in Scala is written in small letters, and here we gotta say true with a capital T. All right, then we say option separator is also true. And then we say load and give the exact same file path, hdfs // Titanic.csv. Hit enter. All right, it's loading. Then df.show 10 false. So the syntax of Scala and Python is nearly identical in that case, and it worked. We now know how to start an interactive session with Scala and Python and how to load data into them. Next, we would like to submit files as Spark jobs to our cluster. That means that we have to put our instructions into a file, which we will then submit to Spark. It will be executed just as if we would have entered the code into the interactive shell. Of course, for this, we first need to create those files. For Python, it is actually pretty easy. Just create a .py file and submit it. So let's do the same we've done before, but in a .py file. So first of all, let's exit the interactive shell. All right, and let's create that file in our home directory by using nano. So we say nano, and we say script.py. So the first thing we need to do is import Spark session from pyspark.sql. This is necessary to create a Spark session which is used to interact with our cluster. So we say from pyspark.sql import Spark session. Next, we want to actually create the Spark session. So we say Spark is equal to Spark session dot builder dot app name, and let's call that submitted. And then we say dot get or create. All right. So we've created the Spark session. So it's Spark equals Spark session dot builder dot app name dot get or create. Note that we don't enter the master here, since we will provide all that as command line arguments when we actually submit the job to our Spark cluster. The name suffices here. Next, just enter the commands we issued at the command line. So we say df equals spark.read.format, and that is a CSV file. Option header true, and option separator is a comma, and load hdfs // Titanic.csv. All right, let me just check that. Spark.read.format CSV, option header is true, option separator is comma, and load hdfs Titanic.csv. All right. Finally, we say df.show 10 false. So this will print the first 10 rows of the Titanic dataset to our screen. All right, so save and exit the file. So Control X. Yes, we want to save that. Enter. Since we are still inside the bin folder, we can use the Spark submit script to submit our Py file. So we're gonna use Spark-submit, and then we say master is yarn. The Q is Q is def, and we want to submit the script.py file in our home directory. Enter, and the job is submitted. Now we will receive some debugging info, and ultimately we should receive the first 10 rows of our data frame. So let's just wait. All right, there you can see them, the first 10 rows of our Titanic data frame. All right, let's clear the screen. Now doing the same with Scala is a bit more involved, since we need to install Scala and package our application into a jar file. Okay, first let's install Scala and SBT, the tool we are going to use to build our jar file. We're going to copy and paste some commands, since SBT is not included in the regular Debian package manager. So first of all, let me make that a bit smaller. Right, clear the screen. Then open Firefox. And we're gonna Google Debian install SBT. And then open the entry by Tech Republic. That one is pretty good. And now we're just gonna copy and paste some commands. So down there, it should say something about installing SBT. There is, install SBT. All right, so let's put that over there. Whoops, sorry. Oh. All right, so first of all, we're gonna just copy that command, paste it. And once of course. Hadoop is not able to issue the sudo command. Only my account is able to do that. So we're just going to open up another terminal. Let's hide that for a few seconds. So I'm now logged in as with my personal user account, and then we're just going to paste that command, hit enter a password. All right. Then we are issuing that command.